Hi guys, welcome to Algebra, Financial Algebra. It's week 6 of quarter 3. So today what we're going to be looking at is we're going to be looking at a tax rate schedule. And with that tax rate schedule, we're going to be looking at piecewise functions as well. So what I want you to do is think about that poll. Give yourself 10 seconds to answer it. Well, maybe 30. And then, you got to change it. So looking at the table on the right, how much tax would a person have to pay if their adjusted income is $37,500 a year? Okay, so pick which one you would pick as well. And remember that we're going to talk about that a little later on in the webinar. Okay, so what I want you to think about is the discussion. And when have you come across a piecewise function in real life? And describe or write the function for the situation. So just think, what is a piecewise function? What is it? And what does it do? What does it look like? Have you heard the term before? Okay, in the live webinar, nobody seemed to remember what the term was. And so this will be a good intro into what we're doing. And hopefully by the end of it, you will understand better what a piecewise function is. Just kind of memory lane, at the beginning of this year, we talked about cell phones and we talked about piecewise functions with cell phones. We also talked about work and getting paid different rates with commissions. For example, if you worked in sales and you got paid 10% commission off the first $2,000 you sold and then 15% after that, those would be piecewise functions where the response is different depending on what comes in. Now this tax rate schedule at the top right is going to be represented as a piecewise function as well. So let's go and see how to make it work in it. Okay. Nice. All right. So looking at the tax table on the left, how much tax would a person have to pay? Their adjusted income was $7,500. And so all we're going to do is we just need to look at where does 37,500 fit, and it fits within this bracket here. Okay, so in other words, we have to apply this in order to find out what our answer will be for our taxes that we owe. So we're going to take 5,081. Oh, back up. Control Z, that'll do it. There we go. 5,081.25. And then we're going to add 25% of the amount over 36,900. So we're going to take 37,500 minus 39,600. No, 36,900. Back. 36,900. So then this is going to be 5,081 and 25, and then I'm just going to go put that in a calculator. It's going to be 600 and a quarter. 600 and a quarter. So 600 times 0.25 is 150. So then this is going to be 25 cents, but you can round. 1, 3, 2, 5. So the best answer is $5,231. Cool. All right, so let's look at this. If we were to create a piecewise function out of the tax rate schedule, what I want to do is I want to visually kind of remind you what piecewise functions look like, just as the mechanics of it. Often it looks like an f of x, or it looks like a y, equals, and then we use a big old squiggle. Okay, and then this one we're going to have like 0.1 times x, And then we're going to have a constraint. So we put a comma, and our constraint is x is greater than 0, but less than or equal to 9075. Now what I want you to notice is where I got those constraints. It's kind of cool. Okay, so I look at the first line. 0 comes from the first one. 9075 goes for the upper bound. Okay, upper bound and lower bound. There. Okay. So we have our equation and we have our constraints. And we're just going to do a fancy squiggly. I'm going to rewrite line 1. I'm going to change color so it's better to see. Let's put red instead. Line 1 is red. So the equation is going to be 0.1x. And my constraint is if. If is a good word, 1 is another good word. So 0 just got to be less than x and less than or equal 9075. Now just kind of a reminder, where did we get our constraints? 0 for the lower one. Oops, I did too big. 0 for the lower one. And then 9075 for the upper one. Okay, and the 10% is 0.1. Okay, so all the parts. Now I'm going to show you how to do the blue equation. So what I'm going to do first on the blue equation is I'm going to create my constraint first. Because I know I'm taking this number and I'm taking this number, the 9075 and the 36,900. So if my lower bound is 9075 and less than x less than or equal to 36,900. Okay, then the next part that we have to figure out is we have to figure out how do we write this algebraically. Okay, first part is simply 907. 907. We'll go ahead and put 50 cents because 50 cents counts. Plus 15% of the amount over 9,075. How do we represent that in terms of x? Well, we're going to take x. So if there's $10,000, then all we want to pay is 15% on is the 72 or $92 that's left. So we're going to take whatever tax is, and then we're going to subtract 9,075. Okay, so that's kind of how it works. We get this number is the one that is going to be part of our subtraction part. Okay, I'll give you a minute to think through that. Not a full minute, but a little minute. Okay, for space purposes, let's look at this row here. So that way I can still draw on stuff. Okay, now remember these are my constraints. So I'm going to go ahead and put that first, and I'm going to skip a couple of spaces. So if, and then my lower bound is 186, 350, which is less than x, which is less than equal to 405, 100. Speed, comma. Okay, so those are my constraints. The constraints are kind of easy-ish to figure out. Now we got to come to the equation-y part. Okay, so the first set is we will be paying $45,000 in taxes. 353 and 75 cents. And it says the word plus. So we're going to add 33% as the decimal is 0.33. You can put 0.03 or 0.33 if you wish. And then the amount over, so x minus 186, 350. Okay. So that's how we write it. Now just another note to sometimes like our constraints are shifted by commas or just left there to the side. So I've done, what I want you to do is I want you to push pause right now and I want you to see if you can do 2 of those on your own. So like do the 3rd row and the 4th row. So push pause and then come back and I'll do the answer. Pause. Okay, so that's how it looks. And this is called a piecewise function because we have pieces. This one has 1 piece, 2 piece, 3 piece, 4 piece, 5 piece, 6 piece. It has 7 pieces. Okay. And then the next thing that we're going to do is I'm going to show you how to enter it into Desmos. Okay, so that way we can graph it. So what I'm going to do is and I have a screen where you can push pause, but this is what I'm going to start typing into Desmos. Okay, so you just enter in a line for each one. So I have f of x equals 0.10x, and then I'm going to use the brace if x is less than, it's got to be less than or equal to, and you just type both those, 90, 75. Okay, next line, f of x equals 0.1, oh, we got to include that first part, so 907.50 plus 0.15 x, put a constraint on it for 90, 75 less than x less than equal to, that wasn't an equal to, less than equal to 36,900. Okay, and we'll do one more, do that kind of pinkish colorish one. So f of x equals 5,081.25 plus 0.25 x, constraints with the braces, x, no, 36,900 less than x less than equal to 89,350. Okay, so that's how you put it in Desmos. Now let me show you what it starts to look like in Desmos. And the only way to show you is we have to change the window. Okay, you can zoom out. Oh, I better put a constraint on that first one. I need to make it greater than 0. There. We can zoom out by clicking that button. Or we can change my graph settings. My x-axis is my income, and my y-axis are my taxes. My income, for what we looked at, it goes up to $400,000, so I'm going to make my x's go to 500,000. And x-axis can be, let's do a negative 1,000, negative 5,000. So I can see it. Okay, my y-axis, I'm going to guess that I'm paying up to $200,000 in taxes. I hope not, but it's possible. And then my y-axis, let's make it negative 2,000. And we got to bring this one up so you can see it better. Start to see that. And can you see in the graph that it's in pieces? Little bit pieces, little bit pieces. Okay, and then if we keep going, then we can see stuff. But what I wanted to show you was how to adjust where we are at. And right now we probably don't need to be to 200,000, so let's just go to 50,000. There, and so you can start to see the piecewise function as to what we have going on. Cool, huh? All right, guys. So one thing I want you to do is I want you to think through, let's come back to our tax table. So it's in pieces. What are some things that you notice about the tax table? One thing I wanted to point out is it's called a graduated tax rate. And then we'll be done. Oh, that graphing, you need to make sure you graph because that's for the answers. It's 10% on the first 9,000. Then it's 15% on the next section above it. It's 25%. Okay, this is called a graduated tax rate, as things just increase as you make more money. Graduated, graduated, getting bigger, graduated tax rate. Okay, so let's kind of go back to the graphing part. That's how you enter everything into Desmos. So you can push pause and type and enter into it. And then this is what your graph should kind of look like. You don't see the jumps that you did in the other one because I've got the whole kit and caboodle here. And then you can see what I chose. Where's it at? You can see the windows that I chose. Okay, these were the windows that I chose. And then these were the y-axis windows that I chose. Okay, you can do the same thing or different. All right, guys, good luck. I want you to think piecewise, functions that are in pieces. Some of those piecewise functions can look like parking garages. You know, you pay X amount for the first 3 hours, and then after that it's $5 an hour, or I mean, just all those kinds of things. Cell phones, taxes, piecewise functions. All right, guys, TTFN.